This is part 2 of section 6.1, complements. Recall that two acute angles are complementary if the sum of their measurements is 90 degrees. And if we're dealing with a right triangle, and this is a 90-degree angle, then because the sum of the interior angles of a triangle equals 180, these two angles must be complements. All right, so remembering that, and also cofunctions from the last chapter, we had something very similar to this, and we talked about the cofunctions, and we talked about how sine and cosine were cofunctions, tangent and cotangent were cofunctions, and secant and cosecant were cofunctions. We have the same ideas here, but now that we're talking about them in terms of triangles, it makes it a little bit more obvious that the co part of cosine, cosecant, and cotangent stands for complement. Cosine is the complement of sine. Cosecant is the complement of secant. And what we end up with is this, and we've had this in the previous chapter. We tended to talk about it in terms of pi minus 2 minus theta instead of 90 degrees. But these are the same ideas. It works whether it is in radians or if it's in degrees. All of these hold true. And it makes for some really easy problems, okay? Given that cosine of 37 degrees is approximately 0.7986, find sine of 53 degrees, okay? First off, notice that 90 degrees minus 37 degrees gives me 53 degrees. So sine of 53 degrees can be written as sine of 90 degrees minus 37 degrees, which is the same thing as cosine of 37 degrees, which is 0.7986. Don't overthink these. Given that secant of 65 degrees is 2.3662, find cosecant of 25 degrees. 90 degrees minus 65 degrees is 25 degrees. So we have the same kind of thing happening again. Cosecant of 25 degrees is the same thing as cosecant of 90 degrees minus 65 degrees. And we have cosecant of 90 minus theta, and our theta is 65, so that's equal to secant of theta. So this is secant of 65 degrees, which is approximately 2.3662. It's a useful concept. Okay. Now we're also going to be asked to solve right triangles. And when they ask you to solve it, they're asking you to find the measurements of all the angles and all of the sides. So let's look at some example problems. We want to solve this triangle, okay? We are given angle A being 23 degrees, and we are given our hypotenuse as 5.8. We need to find, well, angle C is 90. We need to find angle B in each of the other sides. So A is 23 degrees. B, I don't know yet. C is 90 degrees. A, I don't know yet. B, I don't know yet. And C is 5.8. Okay? Well, we know that if we add up the angles of our triangle, that they need to add up to 180. So you just need to add 23 plus 90. Basically 180 minus 23 minus 90 is going to give me angle B. And so angle B is 67 degrees. Okay. Now to find these, I'm going to use the angle that I'm given that I know and this. You can use the angles or other values that you have computed, but if you can use the ones that they have given to you, you're going to be a little bit safer, because if you use a number that you may have miscalculated, then you can magnify your little mistake earlier. So always going back to the pieces you were given whenever possible will help you out. Okay, so since I've got this angle and a hypotenuse, if I find sine of 23 degrees, sine is opposite over hypotenuse. So this should be A over 5.8. Okay, so that means my A value is 5.8 times sine of 23 degrees. And that is approximately 2.3. Okay. Now you should, in theory, be able to find B by using the Pythagorean theorem. But since we calculated this and we had to round it, using that as in your calculations can be risky. Sometimes you're not going to be able to avoid it, but it is kind of risky. So to avoid that, to find B, I'm going to use the cosine of 23 degrees. And that equals B over 5.8. So your B value will be 5.8 times cosine of 23 degrees. And that is approximately 5.3. Okay, now a couple of things you can do to ask yourself whether your answers make sense. First of all, your smallest angle correlates with the smallest side. Your middle angle correlates with the middle side, and your largest, which will be your right angle, will correspond with your longest side. If you add up any two sides, they should be larger than the third side. So you kind of have some ways in here to kind of check. It doesn't take a whole lot of thought to double check just that much, and you can catch your mistakes.